Great, good morning. We are going over lab 2, experimental design, different parts of how we would design an experiment, how would we run it, how would we do replications, and we're gonna be using Simutext to do that. Simutext is this online or this desktop app that you should have downloaded by now, and we're gonna be using it again for both this lab and next week's Lab 3's lab. So not next week because we don't have lab next week because of President's Day. So I will see you all in 2 weeks after this. But Simutext, we're just going to be doing 2 exercises on there. So the layout for this lab is first, I'm going to be putting you in breakout rooms for half an hour for the first exercise, and that's going over experimental design. You're going to be looking at the different parts of scientific method and just looking at a case study involving birds. And then afterwards, you're gonna come back to the main Zoom session, and I'm going over a case study, looking at different variables, what do they mean, some definitions, and then I'm putting you back into your breakout rooms, and you will be doing exercise 2, which is going to be looking at the town of Idyllic. It's that 1-minute video that was in the announcement along with the pre-lab link, and it's gonna be tied in with that. And then after you're done with exercise 2, which is gonna be like another half hour, in your breakout rooms, you're gonna come back, we're gonna talk about what you found, how you tested your hypothesis, things like that. And then that is basically it for lab 2. So everything that's due for lab 2 is just through Simutext. There's no post lab. So once you're done with both exercise 1 and 2 through Simutext, you don't have to turn anything in afterwards. And that would be the end of lab then. So is everyone okay with, everyone is okay with downloading Simutext onto their own computer? Yeah? Okay. Okay, so let me just share my screen then. But if not, I still know that maybe there are a couple of people who don't have Simutext yet. And if that is still an issue, you can just let me know. Okay, there's something in the chat. Okay, right. So Simutext, if you wanted to download it, if you go into Canvas Lab 2, there's also the before lab. If you scroll down, this is the link that you would click into, and this is the key, the access key that you would type in. Our section is section 17. You would put in for your student ID, your school name, whatever username you have. And let me check the chat again. Does it cost money? It does not cost money. It's free. If anything, there should be more than enough access keys for everyone. More than enough for all of the labs. So it does not cost money. So if you just go into Canvas, this is the registration link to download and get to there. And this is the access key that you would put in. Yeah, so again, we're section 17, but it seems like a lot, like more than half of everyone has already downloaded Simutext. So I'm just gonna go over what that would look like when we get started. So if we click into Simutext, you're going to be given on the main page, we have Isle Royale and Understanding Experimental Design. Isle Royale is going to be for Lab 3, where we're looking at predator-prey relationships and things like that. So, but today we're looking at Understanding Experimental Design. So if we just select that, it's going to take us to our main exercise for today. So in the main page, we have section 1, 2, and 3. Section 1, that's when the first breakout room, and then section 2 is our second breakout room. We are not going to be doing section 3. These are additional graded questions that we won't be looking at, but your progress in Simutext is going to be charted online. So you, like, once you finish Simutext on your own computer, I can track your progress through the instructor portal. So that, okay.
Maggie, I'm still seeing the Canvas page. Are we supposed to be seeing the Simutext one?
Yeah, sorry, let me see that again. Oh, and okay. Sorry, let me just try again. Okay, can you guys see? Okay, let me start again. So back on the main homepage, but before I move on, there is a chat. Oops. Okay. There's a chat. If your laptop doesn't accept Simutext, then you are going to, I'm going to be putting you in breakout rooms and you're going to be working together in your group. So your progress should be around the same. So if you just work with your group, then I'll just grade you on their progress too. So that's, if you don't have Simutext now and it's because your computer isn't allowing it, or it needs to be like updated or something. For today, for today it's okay because I'm gonna have you work with your groups, but next like in 2 weeks, we're still gonna be using Simutext, so maybe we can, we'll try to figure it out before we use it again. But it's just for these 2 labs that we're using this app, so that's that. But right, so if you click into understanding experimental design, again, in the next page over, we're given the main homepage, the contents. There's 3 sections in understanding experimental design. We're not doing section 3, just section 1 and 2. So the first breakout room, you're just doing the section 1. And say if we just click in, let me show you the layout of everything. Some background information on what makes a good experiment. It's going to go and talk through different things like, this is the video that you guys have probably seen in the announcement, that 1-minute video that you can watch. But there are going to be some questions that you're going to answer, but it talks a little bit about the scientific method, some background information on that. And say you have, now that we're onto some case studies, when you do answer some questions, say you check your answer and it's not correct. It's okay. It gives you as many chances as you need to eventually find the correct answer. So if you want to check again, that's totally fine because Simutext is graded on completion. So if you take as many tries as you need, you can, and if you want to. So eventually, it'll talk a little bit more about independent variables, experimental control groups, confounding variables, dependent variables. And when you're done with your first breakout room session, and then when we come back in the main group after that, I'll be going over another case study to talk more, just to go over how can we identify these different variables. So that is the layout, or it's a little intro on exercise 1. Did anybody have any questions about like Simutext or anything like that? Okay, awesome. So I will be putting you in breakout rooms. You're gonna have around half an hour for the first breakout room to work on exercise 1. And I will be popping in and out to see everyone's progress, answer any questions, things like that. So let me just put you in your breakout rooms now. Okay, so for half an hour, I'll see you in 9:10.
Are you allowing us to share our screen or not?
Yeah, you are. Yeah. So just share your screen with your group if you ever need help to check anything. Yeah.
Okay, so are you make changes on Zoom so we can
you're right.
access? We can allow to share our screen.
Yeah.
So I'll go. And I don't have a Simutext right now.
Oh, okay, that's totally fine. In your breakout room, just explain it to your group, and then I will track your progress based on their progress. But also, if there is still problems because we're using it for the next lab, we can try to figure out how to get it.
I can download today. Okay.
Yeah, of course.
Because I don't know about that. That's why.
It's totally fine. Okay.
Thank you.
Yeah, of course, no problem. So now I'm going to go over a case study in exercise 1. It looks like everyone's been doing really well with exercise 1. You're making really good progress. And but for like the first part, I remember you're going to go through different variables and definitions like the independent variables, confounding variables, dependent, all of that. So this, I'm going to be going over a case study to help us have some practice at identifying that. So I will share my screen and we can go through this case study together. So for exercise, for this class exercise, let me just read you our case study. We are looking at a university professor that notices students who take lecture notes on their laptops tend to perform worse in her class compared to students who take notes by hand. She hypothesizes that the act of taking notes on a computer leads to reduced retention of information compared to taking notes by hand. To test her hypothesis, she recruits 50 undergrads from her institution to take part in the study. Participants are randomly assigned a note-taking strategy, either by hand or on a computer. They are led into an empty classroom and are instructed to take notes as they watch a 15-minute pre-recorded lecture. The following day, the participants are asked to return and are given a quiz on the content of the lecture. So we're just going over 5 questions. The first one, which of the following is the independent variable in this experiment? So the independent variable is our treatment variable. What we're changing in our experiment to see if the outcome changes. This is what we manipulate. So the independent variable, we're given 4 options. A is note-taking strategy. B is lecture students watch. C, quiz performance. D, the number of participants. So if we're thinking about the independent variable, what are we changing in our case study? We can say that we're not changing the lectures that students are watching, so we can cross out B. The quiz performance is based off of what we're changing, so we can take that out, and the number of participants don't change. So we would say A, our note-taking strategy, is our independent variable because we're looking at, we're changing how students take notes, either by hand or through their computer. So we can say for question 1, our independent variable is A, note-taking strategy. For question 2, which of the following is the dependent variable of the experiment? So the dependent variable depends on our independent variable. This is what we're trying to track and change. So for our dependent variable, we're looking, this is a variable that we're looking to measure the experiment's outcome. So if same options are given to us, A, note-taking strategy, B, the lecture students watch, C, quiz performance, and D, the number of participants. So what are we trying to measure? What are we tracking at the end of our experiment? What are we trying to see that changes? So note-taking strategy, we already know is our independent variable, so we can take that out. The lecture students watched is not going to depend on what note-taking strategy they're doing. The number of participants, again, do not change. So we can say that C, quiz performance, is our dependent variable because how we're trying to track and measure, is there a difference between the 2 different note-taking strategy? And this is, does quiz performance depend on note-taking strategy? So C would be our dependent variable. For question 3, what are the experimental units in this experiment? So experimental units are the subjects of treatment. What are we applying our treatment to? What are we applying our independent variable to? So quiz performance, we just talked about in question 2, is actually our dependent variable. B, note-taking strategy, is our independent variable. So we can cross B out. C, the lecture that students watched. D, and this is the students. So if we're thinking about experimental units, what are we applying our treatment to? Our independent variable to, our note-taking strategy, we are applying them to the students. We are having our undergrads take notes either by hand or on their computer. So our experimental units in this experiment is D, the students. this is what we're applying our treatment to. So we can say that it is D. So for question 4, which of the following potentially confounding variables is least important for the professor to hold constant? So a confounding variable is something that we're going to hold constant throughout our entire experiment because we don't want this to change our final outcome. And this is, we're trying to see which one is the least important that we don't have to worry about, so it would not affect our final outcome. So if we're looking at our options, we have A, the lectures that the students watch. So if we change the lecture that the students watch, would the quiz performance and the quizzes that they take, would that change? I think it's pretty important that one of the things to keep constant would be what they're watching so that we can track what their quiz performance is at the end. So it's pretty important. So probably wouldn't want to change A. B, the amount of time between watching the lecture and taking the quiz over the material. So if we say that one group took the quiz the very next day, but then the other group took it 2 weeks later. And so retention of the information would probably have an effect on their quiz performance. So this is pretty important too. So we probably wouldn't want to change the amount of time between watching the lecture and taking the quiz. So B is pretty important. C, the temperature of the room in which students watch the lecture. So we probably wouldn't want to worry about this, but if it was either too hot or too cold, it could affect their quiz performance. So that's important, but probably not as unimportant as D. So the clothing students wear to watch the lecture. If I was a researcher and I was asked to put in money and time to control certain things, I probably wouldn't want to put in the effort to control whatever they're wearing while they're watching the lecture. So D would be the least important confounding variable because we probably don't really care about what they're wearing, but we probably want to hold other things constant, like when do they take the quiz, how long after they watch the material, what do they watch, what lecture do they watch, and then probably the temperature of the room. So we can say that D is the least important confounding variable that we have to look at. So that is question 4. Question 5, which of the following ideas for increasing replication is most likely to improve the ability to test the hypothesis that taking notes by hand leads to better retention of information compared to taking notes on a computer? So what can we do to our experiment? How can we replicate it in multiple ways so we have a better outcome, so we can be more confident in our final results? How can we replicate within our experiment to just have a better final conclusion, or at least have more confidence in it? So a couple of ways if we wanted to replicate it. So a couple of options that we have is A, increase the number of students assigned to both note-taking strategies. So just put more undergrads to take notes by hand or to take notes by computer. B, increase the length of the quiz that students take after watching the lecture. So just make the quiz longer. C, increase the length of the lecture that students watch and take notes on. So have the lecture maybe instead of 15 minutes, maybe we'll have it an hour or something. Or D, increase the number of students assigned to take notes on a computer. So if we're thinking about how to increase replication and overall increase our final confidence in our outcome and all of that, we probably don't have to worry about B and C, because increasing the length of the quiz and increasing the length of the lecture that they watch is not really important to us. So now if we're comparing A and D, if we wanted to either increase the number of students assigned to both note-taking strategies for option A, or increase the number of students assigned to taking notes on a computer to just one group, we would probably want to choose A, where we're increasing the number of students to both note-taking strategy groups. So the replication would increase. We would put in more students for both of those note-taking strategy groups. And I think from then we would have, we would increase replication and improve the final ability to test our hypothesis that way. So we can lean towards and say A. We would just put more students in both note-taking groups. So these are definitions that I think you've gone over in section 1 or exercise 1 in Simutext. And this is our case study to look at that. Now, if I'm going to share Simutext, can you see this screen, Simutext right now? No, okay, let me try again. Now? Okay, awesome. Let me go back to the home page and let's go to exercise 2. So for exercise 2, we are looking at the symploids. So if it can. Okay, so our case study now is that we're trying to save the symploids. The symploids are these little creatures that only eat grass. They're in this area and they're affected by something. We don't know what they're affected by, but they are getting sick and they are dying and we don't know why. We are trying to figure out why they're dying. So we're going to be putting together an experiment. We're going to do some replication on through section 2. And as you go through, there's some background information on the very first slide. This is the video that I think it's the same video again for the symploids that maybe was attached before. So you can watch that. It's a little background information, but as you go through, more questions for you to answer. And there are some graphs that you can adjust. So right now on this graph, we see symploid disease. We can look and track the different trends to maybe see, is it because of sham worm infestations? Is it because of these parasites? As they're increasing, we can see that it could probably be this. Is it because of increasing temperatures or zap weeds, which is the herbicides that's being applied to the grass? We're just looking at these different trends and we can start to get an idea of what do we think is the issue. As we go through, you are looking more at different trends too before you form your hypothesis. So on the side, there's another plot where as the color increases, the population density also increases. So the darker the color, the more symploids live in this plot of land. You can also see, you can track symploid disease rate, symploid death rate, and see, is there a relationship between the two? And then if we move on, eventually you would form your hypothesis. You would say, maybe I think it's because of herbicides. That's why they're getting sick and they're dying. Or maybe it's because of the parasites. And as you go on, you're going to test your hypothesis by making plots and setting up your experiment. So this is a setup practice where you can add as many I think 60 symploids, and they also need to eat, so around 60 plants. Say if we wanted to have a control, just an example, we probably want to put nothing in there. We don't want either herbicides or parasites. So we'll just say no herbicides, no parasites, and we can enter our label here and say control. This is just a practice setup for it, but this is how you can adjust your plot. But if you wanted to add herbicides, you can just click, yes, we want herbicides. Yes, we want herbicides and parasites, or just parasites, something like that. But if you keep on going forward, eventually you will be conducting a test. And this is more of an example practice. So let's say when you're ready to begin your test, it will, let me go back. You can start adding your study plots. So that is what I went through before when you adjusted the amount of symploids in your plot, the amount of plants in your plot, adding in herbicides or parasites, or both or neither, or one of the other, things like that. But this is exercise 2. And you will have another half an hour to do exercise 2 in your breakout rooms. So did anybody have any questions before moving on and going into that? No? Okay, great. Maybe I'll give you a little bit more than half an hour. Since it's 9:26, I will see you all at 10. But before then, I'll probably, oh, somebody raised their hand. Yes.
Sorry, I was just wondering, like, are these things like graded?
Yeah.
Like, for example, like when we answer like those questions, like, are we graded for those?
Yeah, so your progress is tracked on the instructor portal for Simutext, but it's graded on completion. So just trying, and you get unlimited tries for each question. So eventually your progress, your final score of like which questions you completed, that is going to be your final grade. I will see that on my end, but you're just doing these 2 sections. I know that section 3, it says that it's the graded section, but we're not doing that section, but yes. Yeah, so grades for this should come out pretty soon afterwards, but yeah, you should be able to finish this before you leave lab today, but it's not, all labs aren't due until we meet the following lab. So if you can't finish anything today, and if you want some extra time, you can just finish it before we meet for lab 3, basically. Okay, awesome. So I will put you back in your breakout rooms. You'll have a little bit more than half an hour, so like 33 minutes to do exercise 2 as a group. I will pop back in and out to ask and see if you have any questions, but okay, I will see you all at 10. So, yeah, if you have any questions about your Excel sheet for lab 1, how to do any of it, or if there's any problem submitting it, you can again submit it to my email, anything for lab 1. But it looks like everyone's doing well with Simutext, and I think pretty much all of you are finished with exercise 2. So did anybody want to talk about your hypothesis? What did you find? What was the reason why the symploids were getting sick?
Our group figured out that the symploids were getting sick because of the parasites, and it wasn't related to the pesticides. It was directly related to the parasites.
Okay, great. Yeah, I think running through a couple of times, yeah, doing like replication and having your controls down, that sounds great. Did anybody find anything different? That sounds great.
My group actually ended up splitting down the middle. So 2 of us started with the herbicide and 2 of us started with parasites. And we found that whichever one we did second actually ended up causing the sickness for the symploids.
Interesting. Okay.
So it was herbicides and the other 2 it was parasites.
Interesting. Maybe then that could be for future studies where you do more replications. Now you know, maybe we should add in more study plots to see what was the real reason why. But yeah, it could be a combination of both. It could be just one or the other. Interesting. Okay. Did anybody else want to share what they found in their group? If not, I think everyone's been doing really well. So again, after you're done with exercise 2, that's it for lab 2. Let me share my screen. Again, we are not meeting next week because of President's Day. So we are meeting the week of February 22 for lab 3, Isle Royale Population Ecology, where we're using SymBio again. So so if you don't have it onto your computer, that should be more than enough time to either do any of the updates that you need and get it onto your laptop. But yeah, we're using it again for SymBio, but these are the only 2 labs where we'll be using this program. So after that, you can just delete it off of your laptop. But that is basically it for lab 2. If any of you guys want to stay and have me check if you're missing any of the questions on SymBio, or if you had any questions about Lab 1, how to make certain Excel sheets or Excel charts, like any problems with that, you can just stay after lab. But that is pretty much it. I will see you all in 2 weeks, and I hope you have a good rest of your day.
Thank you.
Yeah, thank you.
Thank you.
Yeah,
Thank
thank
you.
you. Bye. Okay.
Hi, I have
Hi.
a question. Yeah, about the lab one. So I submitted graphs and